Welcome to Walkabout the Galaxy, the New Year astronomy podcast where the science is universal, the opinions are personal, and all our counters are reset to zero. We are Strange Charm, top and down the astroquarks, also known as Josh Caldwell,
Addie Dove,
Jim Cooney,
and Audrey Martin.
There it is again. The Vermont delay.
The Vermont lag.
Coming to you from the Walkabout studio at the University of Central Florida with 3 real quarks and 1 virtual quark, and I think we'll be talking about more virtual stuff later. Did you say? Quasi stuff.
Quasi stuff.
Yeah.
I don't know, virtual. Yeah.
Okay, maybe you're a quasi quark today.
All right.
With the delay. Be sure to follow us on Instagram and anywhere else we may happen to show up, but mainly Instagram, and catch our videos on YouTube. We are at Walkabout the Galaxy. You can email us at wtg@ucf.edu. Our stumper today is inspired by launches which are anticipated to happen perhaps before this episode publishes.
Oh.
We've got integrated flight test 7 of the Super Heavy Starship system from SpaceX, anticipated for January 7th-ish, I believe. And then we have the first flight of Blue Origin's orbital New Glenn rocket scheduled for January 5th-ish or 6th-ish in a couple of days. Today is January 3rd-ish as we're recording. And so your stumper is also partly inspired by the upcoming movie adaptation of Andy Weir's novel Project Hail Mary. You're familiar with this?
No.
Oh, I didn't know. I read that one. Well, I didn't finish it.
I read
Ringing endorsement.
I read Artemis and the Moon one.
Yeah,
or the Mars one.
I read Project
The
Hail
Martian.
Mary.
Project Hail Mary. I liked Project
Is that
Hail
newer?
Mary better than the Moon one, I think.
I don't know.
Have you read any of these, Jim?
I read the first part of Project Hail Mary. I will continue. I enjoyed it very much. I'm just not done yet.
Okay.
Don't spoil it.
Oh, so it's newer. Or we're just all really out of date.
You are out of date.
I know.
They are making a movie adaptation of it, but the relevant point of this for the stumper is that in Project Hail Mary, there's a certain similarity to The Martian in that a lone individual finds himself in a save the world. Actually, I guess in The Martian it was save himself situation.
Himself, yeah.
This one is sort of a save the world situation.
Save the cheerleader.
He's off on a rocket on a Hail Mary project.
Oh, this is different than Slingshot. Still need to watch and make fun of.
We do.
Oh, true. Yeah. So he's on a Hail Mary project. So the stumper is, suppose that you are tapped to do a Hail Mary project. And the Hail Mary, all you have to do is
throw a Hail Mary.
Is orbit the Earth. Okay. So you don't have to go in interstellar space. You don't have to go to another planet. You have to orbit the Earth. And if you survive and come down, it's all good and you've saved the world. But you have to do it immediately on the next flight of one of these 3 vehicles. The 7th test flight of Super Heavy from SpaceX.
Oh, God.
And they'll reprogram it so that the ship isn't landing in the Indian Ocean.
Sure.
Okay.
Sure.
But they'll reprogram the flight profile. But it's the next flight of the Super Heavy with Starship. You're in Starship. It's Artemis 2. So the next flight of the NASA SLS with an Orion capsule on board. You're in the Orion capsule. Or it is the inaugural flight of New Glenn, and we're going to stick something up there in the payload bay that can carry you safely. Let's make it a Crew Dragon. I don't know if that fits, but it should.
Let's pretend.
It's got a big old whopping payload bay.
A New Shepard capsule.
Well, there isn't a New Shepard capsule. Oh, there is a New Shepard capsule, but it's not designed for orbital reentry.
I know.
So let's make it a Crew Dragon.
Okay.
Yeah.
Crossing
when you
your
said New
companies.
Shepard capsule, I was thinking New Glenn capsule. So which one of these relatively untested launch vehicles will you choose to go on to save the world?
Maybe the next Artemis one?
Artemis 2?
Yeah, I don't know if that is the safest, but it feels the safest.
Okay.
It's more tested.
Yeah.
Yeah.
That's what I was going to go with, too, just because I feel like NASA, I think that's the whole thing. Like, NASA is super careful, which is why it's so expensive and takes so long, and why people, they want to go with other directions to go faster. But I'm going up on the Artemis, man.
Okay.
Yeah.
Addie also?
I could say New Glenn just to be fun. But your heart
there's
not actually a capsule for that one. So
your heart
I'm also going to say Artemis, too.
Yeah. Okay. Fair enough. So our faith is with, and to be fair, Artemis did, what has it done? It went to the moon,
Artemis
right?
1. It went beyond the moon. It went
Yeah.
really far,
Yeah.
and then it came back,
Went
and
to
then
the
it
moon,
had a
and
re-entry.
the capsule survived a
Yeah, there's actually a
re-entry.
really interesting report that came out because one of the big concerns, this is a space news thing. That's I don't know how outdated it is, but I'm transitioning into a space news.
Okay.
Is that acceptable?
Well, we have our stumper.
That wasn't the stumper?
I mean, we have our
Sponsor?
sponsor.
Okay,
One of
I'll
those
wait.
S,
So it transitions
we have
to
one of those
space
S
news, so-
words that we haven't done yet.
Yeah, they got a lot of data, and it was it was overall a really successful flight. So
Yeah.
and it's basically the same capsule for Artemis 2.
Great. Go Artemis 2. All right. Well, we will talk about that. And there's a lot of space news, so we'll catch up on that. Plus a bunch of weird stuff, weird moons, weird particles, weird lightning.
Weird lightning.
And all of that. But first, this episode of Walkabout the Galaxy is brought to you by gravitational scattering. Whether you've been stuck with dead spots in your lawn from uneven spreading of fertilizer, frustrated by knots of people leaving an arena, or just generally stymied by crowds and traffic, consider opening up your world with gravitational scattering. With as little as one single central mass, gravitational scattering can handle any number of particles you throw at it and distribute them equitably throughout phase space. Throw in a second massive object to provide an even more chaotic and less predictable and less crowded outcome to your population of planetary bodies or any kind of bodies. Make space in your life with gravitational scattering. Gravitational scattering. Resolute. Relentless. You'll never get it. So
Resolute.
Energizer batteries.
Swiss
Oh, that's
knives.
excellent guesses that make
I was
more
gonna
sense than the
say-
actual correct answer, which is why I said you'll never get it.
Some sort of
Marshmallows.
sailing ship.
Also, so the Resolute sounds like a sailing
Yeah.
ship. Yeah. Dyson,
Oh,
for some reason.
they're really intense.
Yeah.
I do.
There's
really like
They
my
make really
Dyson
good vacuum products.
Yeah.
and
I love it.
Sort of the
air-blowing
opposite of
products.
scattering.
They make products that blow
Oh.
air and suck air.
That's true. They do blow.
Oh yeah.
They do blow air.
The air dryer.
So that's
and
in the
air
scattering realm.
Cleaner things.
Right. Hand dryers, stuff like that. Yeah. Okay.
Wow.
You're
Wait, what was
welcome.
it?
Dyson.
Gravitational
No, what was the-
scattering.
Gravitational scattering.
No. What was the tag?
Resolute. Relentless.
Relentless. They are relentlessly
wonder I forgot that.
sucking up that
That
dirt
makes no
in
sense.
your carpet. I know.
Right.
I don't want my products to be relentless.
No.
That's a little scary.
Especially if they have like one of those vacuums that maps out your house and then just like cleans.
A robot
Relentlessly.
vacuum.
Calm down,
Relentless.
dude. Calm down.
Right. Yeah.
Mine is on the fritz. We've replaced many of its parts, and I'm really sad because we might have to actually replace it.
Your robot vacuum.
My Robo Rock. We call it Dwayne.
Oh, and renamed our Robo
Dwayne,
vacuum.
the Robo
also.
Rock vacuum.
Cedric.
Get it?
Yeah.
Ours was named Cedric.
Is he an entertainer?
Well, not really.
Oh.
Yeah. And also, it's also just not used. So,
We use Dwayne a lot, and we've replaced several internal components, including the motherboard.
Dwayne or Wayne?
Dwayne.
Dwayne.
The Rock
The Rock vacuum.
vacuum.
All right. Now you can tell us about your space news.
Oh yeah. So related to the question, so the Artemis, this came out a while ago, but I don't think we've talked about it. So there was a report that came out about the Artemis heat shield.
Right.
So that was the thing that suffered some, and I was reading about it recently again. So suffered some damage during reentry. And that's been one of the primary concerns about Artemis 2 and the Artemis mission, the capsule moving forward, is that the Artemis capsule has a heat shield on the underside, just like old school Apollo ones did.
Right.
But it suffered some damage during reentry, and it got this cracking and other things in the tiles.
E.
Not great. You
No.
want your heat shield to be heat shieldy.
Yeah.
And so it turns out that the reason that probably happened, so they've done all this really cool engineering and all this really cool research to understand why it happened. It has to do with the porosity of the tiles and gas getting trapped in there. And so they did this maneuver called a skip maneuver, where they came in the
Right.
atmosphere, skipped a little bit, and then came back, and then
Right.
to sort of allow them to bounce down stream a little bit, down atmosphere a little bit, and come in at different entry points. That gives them more latitude on where they can actually enter the Earth's atmosphere and land
Right.
than in the Apollo days. But that maneuver itself, it trapped the gases, and it was an impulse thing. And so then when it re-entered, they didn't have anywhere to go. And it was so it's that maneuver that caused this, they think.
Oh, interesting.
So they're going to do a different, so the heat shield for Artemis 2 is the same. So they're going to have a different re-entry then for a profile for Artemis 2, and then they've done all these modifications and figured out the porosity they need and all this stuff to make it work properly for Artemis 3. So in Artemis 3, they'll be able to do it with
But Artemis 2 is going to have people.
Yep.
Artemis 3 is going to have people.
Yep.
And Artemis 3, then they're going to be doing this dangerous thing.
They're doing
but
the moon.
Nominally fixed.
Yeah.
I mean, in terms of the re-entry.
Yeah.
Just seems a little bit.
They might try to do it with the regular reentry first, but they'll have the new tiles that they've done like crazy amounts of testing on because they know the failure mode at this point.
Right.
They'll have another set of data from Artemis 2 by then.
Okay.
So
yeah. Cool.
It's cool.
All right. And all of you will be on Artemis 2 as we've established in the Stumper, saving the world somehow.
Exciting.
Yeah.
Yes.
You know us, just some heroes.
Some heroes.
Mm-hmm.
Yeah.
Mm-hmm. Let's see what else. So New Glenn, you mentioned.
Right.
So New Glenn is on the pad. Audrey and I saw it.
Mm-hmm.
She's real big and real shiny.
Mm-hmm.
Audrey or yes, New Glenn.
Both of us.
Also, both. Yeah. And they did a hot fire test like just before New Year.
Yeah.
It was very blue and very glowy and very rumbly.
It's blue because they're using liquefied methane as a fuel, which is unusual.
Better than like hydrazine and stuff.
Okay. It just sounds like it would smell bad
It looks really
but
pretty,
you know
though.
why you know why natural gas smells bad.
on purpose, right?
We add a stink to it.
Yeah.
So that you know that there's a leak, which
Right.
I don't think they do that for the rocket.
Well, that's nice.
Everybody adds a little stink to their natural gas.
Yeah, we have a funny, not going to go into it, but there's a family story about us camping, and it's like, boy, this town stinks. But it was our leaking natural gas.
God.
Or propane tank or whatever. It's like, man.
I'm glad that's a
what
story
a
you're
dump.
telling.
This place is just awful, you know. It turns out we're so stupid. We didn't know.
Hey, but you're alive, so that's great.
Yeah.
Wow. Yeah. Yeah. So New Glenn is going to do a test flight.
Right. And they are carrying some sort of payload called Blue Ring.
Blue Ring, yeah.
Which is what exactly?
It's part of their prototype for a next generation low Earth orbit space station.
Okay, cool. So it's sort of like a node or a docking mechanism.
I don't know. Like their whole space station concept is called Blue Ring. So it's not just for docking.
I see. Okay.
Yeah. So it's like a prototype component for that.
I see. Okay.
Yeah.
And this will be a hotel in space or research facility.
They want to be able to do research up there. They've been talking with the science community for a while. So there's a number of companies that are working on commercial low Earth orbit destinations, CLDs, whatever. Commercial LEO destinations.
Okay.
And they've been talking with folks who use ISS or are interested in doing research on station, and obviously like a lot of commercial interest too. But,
Right.
yeah,
Okay.
not
Cool.
just a hotel.
Integrated Flight Test 7, which we mentioned earlier.
Yeah.
Super heavy SpaceX Starship thing. Disappointingly, perhaps to some, the Starship is still not doing a full orbit, not doing a recovery landing. It's landing in the Indian Ocean again, apparently.
Man, how many starships are in the Indian Ocean now? 5?
I know.
Like, are they fishing them out?
I know.
Or are they just filling up the Indian Ocean with starships?
We're filling up the Indian Ocean with starships, just like we're filling up low Earth orbit
Well,
with
this would be an
Starlink
interesting
satellites.
calculation. Is like what displacement of the like how much volume is being displaced? How big is the Indian Ocean?
It's a lot bigger than the Starship.
Well, sure,
yeah,
but
yeah.
Be an interesting
And
calculation.
then they will attempt to use the chopsticks to catch the booster.
Okay.
Last time that seemed to be on track, and then there was a last-minute sort of auto abort by the rocket where it decided that all systems were not go. And it's kind of, it's a very, the launch tower itself is a very valuable commodity. And they learned, they didn't learn it, but that was illustrated with the very first test of the Super Heavy, where it was kind of destroyed, or at least not the tower wasn't, but the pad was so eaten up. So they really don't want to have the rocket explode or crash into the tower.
It's not desired.
They would rather dump the rocket in the ocean in the Gulf of Mexico and build another rocket, because they got an assembly line for those things, and they're actually easier to build than the launch tower, than risk having it come back and blow up the launch tower.
Wow.
And have to build a new launch tower. So that's a kind of a thing where they really are I suppose, trying to err on the side of caution, make sure we're 100% sure that this thing's not going to destroy our launch tower.
Yeah, which is funny because you mentioned like the first launch tower, they were like, whatever, we'll build another one. And then they were like, oh, maybe that's not a great idea.
Yeah.
The other big exciting news that was announced.
Yes. A little bit closer to home.
A little bit closer to home / closer to the moon is that the NASA announced the lander and rover provider for the LunarVise mission were selected. Yay! So this is our mission. I'm the deputy PI, and it's a mission to the Gruithuisen domes on the lunar surface. And we've been building our instruments and doing our science and stuff like that, but we didn't have our lander yet. And it was selected and announced that it's going to be Firefly. So the Firefly Blue Ghost 3 mission will be going to the lunar surface in 2028.
Using air quotes.
Yeah, hopefully 20. We're there. They said 2028. I'm hopeful. And
that
it
sounds
has
realistic
a
for crying out loud.
rover that is provided by Blue Origin / Honeybee.
Oh, cool.
Yeah,
That's exciting.
Pretty exciting.
So cool.
Yeah.
And the Blue Ghost 1 mission is set to launch this month.
Oh, cool.
Yeah.
Really?
And what is it doing?
It has a bunch of NASA payloads on it. So, like, there's a couple payloads from Kennedy actually on it that are studying dust.
Where is it going?
The moon.
Is it landing or
I think it's more
orbiting?
polar. It's landing. It's a Blue Ghost. So it's their first lander.
And it's landing, doing a polar landing?
Let me check that.
And it's a stationary lander, no rover included.
Correct.
Right. And
Yes.
so just a reminder, LunarVise, your team with Carrie Donaldson-Hanna, the PI, are the science leads and leading the development of a bunch of instruments that are going on a lander and a rover. And so you're in charge of all of that. And then NASA separately competed bids to provide the spacecraft that's carrying all those cool science instruments to these weird extinct volcanic domes on the lunar surface. So that's cool. Congrats.
Thanks. We're excited. Yeah, these are part of the CLPS program, the Commercial Lunar Payload Services is how they book these land. It's like FedEx to the moon, kind of.
Cool.
Except they provide us with a lot of other things too. But they're also, iSpace is launching on the same vehicle, it turns out. So they're also going to launch on the SpaceX rocket. iSpace is another company working on a lander, and they're going to also launch on the same vehicle. And I think they're getting to the moon at different times. Yeah.
Yeah. Cool. Yep. Lots of stuff going to the moon. Talk about dumping things in the Indian Ocean. We're dumping
it's going to Mare Crisium.
I don't know where that is.
That's on the moon.
It's on the moon. It's not polar.
Tell us about your cool, weird lightning.
Oh, yeah.
And then we're going to have special top quark trivia.
Whoa. Okay. So this was just a fun article that I saw in Science Advances or something. I don't know.
Addie loves sparky things like elves and sprites. And Steve.
But this one is about thunderstorms and gamma rays.
Oh.
So it turns out thunderstorms themselves can generate sort of gamma ray glow because they create high energy radiation. And so there was a study that came out a while ago in 2021 where some astronomers using the China's Large High Altitude Air Shower Observatory, HASO.
Okay, I was trying to piece that together
elegant.
there.
HASO was that they had detected gamma ray photons reaching energies of more than 1 peta-electron volt.
Oh, that's a lot of electrons.
And we maybe
lot of
covered
electron
this because I feel like I remember talking about that unit, but it was very high energy. And they said they detected this, but some more recent modeling and research is saying like this is potentially not quite true. So
what's not true?
Those were the actual energies of the gamma rays from space.
Okay, so there were gamma rays.
There were gamma rays, and there was energy detected at that energy. But it's possible that it turns out that thunderstorms can also generate gamma rays, and that it could have been coincident timing of like the gamma rays coming in and interacting with a thunderstorm and enhancing the gamma ray energies to these high PeV energies.
What?
Weird.
Yeah.
Okay. I don't know how that works.
I don't think it's the gamma rays from the thunderstorm. I think it's the powerful electric fields from the thunderstorm like
accelerate
ramping up the energy
accelerate
of
the gamma rays.
existence. Gamma rays, yeah.
So you have
Not accelerating, obviously, but yeah.
you have astrophysical
Enhancing.
you have astrophysical gamma rays.
Right, and then they get that already have a huge amount of energy, but then they get a boost of energy from the crazy electric fields of the thunderstorms, and thus you read them as peta electron volts when actually they were 10 or 100 times less energetic than that when they entered the Earth's atmosphere. Maybe, right, but so I think what they want them to do, right, is to like. They want those researchers to figure out whether there were thunderstorms in the area at the time.
Yeah.
I see.
They're like, can you tell us when your observations were and get the weather data from that time and see if it coincides or not?
But if there were no
this other study was looking at the thunderstorm ground enhancements, TEGs, of just sort of like other cosmic, just sort of generic cosmic ray flux. So looking at cosmic ray flux during thunderstorms and saying like, okay, well, you see these enhancements happen in regular thunderstorms. Were these things overlapping?
Okay.
Okay.
So the thunderstorms are accelerating somehow the gamma rays. Is that what you're saying, Jim?
Not accelerating, obviously. They're all
enhancing.
C, but yeah, they're just giving them more energy, boosting their energies.
Right.
Potentially. I mean, that
it's
like
a
Eddie
question.
said, that happens. But the question is for those, because those peta electron volt things, it's crazy high energies, and we don't understand how you would get
peta is 10 to the what? 15.
15. Yeah. So these are crazy high energy things, and it's hard to imagine.
Right.
Cosmic rays being
the light. The light that we see with our eyes is sort of in the ones of electron volts, right?
Yeah. So we should be careful here, because it's not the gamma. The gamma rays aren't the cosmic part. The cosmic rays are protons or electrons that hit this, and we don't directly see those. What we see is the shower of particles that are produced as those things smash into the upper atmosphere.
Yeah.
And the shower of things produce gamma rays. And so then maybe the gamma rays from the electric fields and the gamma ray glow that Eddie was referring to from the thunderstorms are enhancing these gamma rays, and thus when we
work it
together
back
the puzzle
to say how energetic was the
how
cosmic
energetic
ray.
was the thing, we might come up with an answer that's too high if there's thunderstorms in the area.
Can thunderstorms
so
produce gamma rays with that high energy?
They produce gamma rays, and they just have
high,
powerful electric fields which enhance those showers of particles.
Okay, so they do produce gamma rays, but gamma rays with lower energies.
Yeah.
Okay.
Yeah.
So
I mean,
in any
gamma
event,
ray.
all you need to do is figure out if there were thunderstorms, because those very high energy particles are hard to imagine how you'd produce those things. I mean, that's way more powerful than the particles that we produce in the LHC or something like in the big particle accelerator.
Okay, so I think
are we producing this?
I may have scrambled in my brain while you guys were talking about this between cosmic rays and gamma rays, and so I think I was mixing up which ones we were talking about at any given time. But in any event, cosmic rays, particles, usually protons, from astrophysical sources, impact nuclei in the Earth's atmosphere, produce this huge cascade of particles and photons, including gamma rays, very high energy photons. And then typically when we detect those things, we piece it back together and say, oh, there was a cosmic ray with X amount of energy. And the thunderstorms can enhance that shower in ways that I don't understand, which would make us infer that the cosmic ray had more energy than it did have.
Exactly. And it could be a pretty big factor, like 10 or 100, right? Factor.
At the same time, I didn't know that thunderstorms could produce gamma ray in the first place anyway.
Yeah.
So that peta electron volt, is that referring to cosmic ray particle or gamma rays, or does it matter?
It's the energy of the original
cosmic ray proton.
Right.
Okay. Okay.
Right.
No.
I don't
And of
think
course,
so.
that
No,
totally.
a handful of gamma ray photons reaching energies of more than 1
Yeah.
peta-electron volt. It's the gamma rays.
It's the gamma rays. This is maybe
rays.
partly why I
Yes.
was confused.
I think, yeah.
I guess I'm confused.
But then if you measure gamma ray photons, then you
I'm
back
not.
out a certain energy for the cosmic rays that's
it's got to
too
be
high
bigger. Yeah.
than what we know of.
Peta electron volt gamma rays, meaning photons. Part of the confusion, of course, is that we're using the word ray here. It's historical significance. Gamma rays are photons, like radio waves and ultraviolet light are, and X-rays are also photons. But cosmic rays aren't photons; they're particles.
Yeah, that's a
annoying.
tricky one.
It's
That's
annoying.
super annoying. Why is it a cosmic ray?
Because we didn't know what the heck we were looking at when we first saw things.
We should change it.
It's true.
Cosmic particles.
Yeah.
Done.
Anyway, yeah.
If I'm honest, I think that the authors of this public article misunderstood, and I think
I think
it's the cosmic ray energy, but I'm not gonna.
Well, so okay,
I'm not
so
gonna
I'm looking
swear
back
that.
at the original the old article of the PEV
Drama.
thing, and I definitely remember talking about this, but it was they detected more than 350 photons with energies greater than 0.1 PeV, and these were photons that were detected on Earth, but it's gamma rays that are produced from cosmic rays,
Okay.
0.1 though.
but still
Greater
in the
than
PeV.
0.1 in
Yeah.
the PeV
Yeah.
realm. Okay.
Oh.
Jim,
Yo,
I'm so glad
So
we
we're
figured that
all
out.
figured out there.
Clear up our confusion with a top quark trivia.
Yeah.
all right.
Or confuse us
Speaking
more.
of things going really quickly through the atmosphere,
Okay, good segue.
your trivia is pretty straightforward, and it's possible we did something like this before,
Uh-oh.
but my memory is bad, so it's fresh to me.
Mine
Great.
too.
You know, and we always have new listeners all the time.
That's right.
And so, here's your question. I think that most of you know what the fastest human-made object relative to Earth is.
We
at this
definitely
point,
did that
'cause we
as
have
a trivia
talked about
before.
that.
I have talked
right,
about
right.
that.
So that's not the trivia question, but
Okay.
but can you tell me what it is real quick?
I think it's Voyager 1.
No.
No.
It's
New Horizons.
it's not New
It's
Horizons.
not New Horizons. It's a
Is it
Voyager
Pioneer
2.
10?
Oh, I should have had this one.
Oh, Parker
No.
Solar Probe?
Right.
Oh,
it's the
right,
Parker
right,
Solar
right.
Probe.
Yeah, it just did a flyby. We forgot
Yeah.
to mention that.
Yeah.
Space
Oh,
news
yeah.
It just did a
Lucy
flyby,
just
and
did a
that
flyby,
flyby,
too.
of the sun.
No.
It just went very close to the sun.
So close.
it did, and during that trip close to the sun, that was the fastest person-made object ever. Right during that, it was
Relative
something like
to the
400
sun.
It'll go real fast.
430,000 miles an hour relative to the sun. And the next fastest person-made thing was another solar probe, the Helios,
Helios.
solar probe. Here's your question: what
Okay.
was the fastest
And of course,
person-made object? Yeah,
I just want to, they're fast because they're falling into the sun.
they're fast. Right? Exactly. It's not like we sped them up
Right.
that fast. Those
Yeah, but we
solar
made
probes fell to the.
I know.
And then
we
it was
launched them up
fast.
at escape velocity from Earth, and then they fell into the sun. Not
Almost,
into, but
just barely
towards-
missing it.
just-
and so
right.
it's just like they're going that fast because that's how fast something is if you drop it from the Earth to the sun.
Right.
Right.
Exactly.
Whereas the
Doesn't mean it's not awesome.
Yeah.
It is
I'm
awesome.
going to
Yeah.
take credit for it. You don't have to take credit for it, but I will.
Audrey dropped it into the sun and it went super fast.
On behalf
But
of
it's a
humanity.
different kind of thing than like Voyager 1, which is going that fast, partly because of Jupiter and Saturn, but also because of the rocket that we built that
Right.
sent it out
Right,
there.
right.
Yeah.
Okay, so your
time.
actual question is, what is the fastest human-made object? What is the fastest that a human-made object has moved through the Earth's atmosphere? Or what object moves fastest through the Earth's atmosphere?
Those are two questions. Do you want the object?
I want the object.
Okay.
I want the object. I don't need the speed, but I'll tell you the speeds. Or if you come
Or
up with
we
both
might
the speed
come up
and the
with that
object,
later.
that's awesome.
Oh,
The
interesting.
top, if you tell me the top two, I'm going to be really impressed.
Human-made object moving through the atmosphere.
You
of the
want
Earth.
you want its speed at what?
How do we define
Because of course,
atmosphere?
what I mean by this, of course, we mean like the Parker probe obviously wasn't moving at 430,000 miles per hour through Earth's atmosphere. It just
Thank
fell
goodness.
towards the sun.
Right.
But some things have
Interesting.
traveled very quickly through the Earth's atmosphere, and you have to figure out what that means.
Okay.
What those things
These are human-made things,
Human-made
not like
things.
Human-made
micrometeorites.
Right.
correct.
Okay.
Obviously, no, I'm not yet.
Cool.
Yep.
All right. Audrey's got some talking about weird stuff.
Mm-hmm.
Moving out now to Pluto.
The Pluto system. Yeah, it's just getting weirder and weirder. So the Pluto system, there's Pluto.
There is Pluto.
Check.
There's a big moon that
Charon.
Charon. I've heard people call it Sharon.
Yes.
Yeah. I've heard people say a lot of wrong things.
Yeah.
And then there
Karen?
are
I say Karen.
Yeah.
Karen.
Yeah. I've heard
Well,
Karen.
Okay. Well, that's fine.
Yeah.
Am I wrong?
I don't know.
We're all wrong.
Charon. Yeah.
Wait,
Fair
what do
enough.
you say?
I say Charon.
I vary for what I say.
Okay. Okay.
Karen.
Karen.
She's a real
spelled,
Karen.
Just so our listeners don't know what our problem is, it's spelled Charon, and it's from Greek mythology. So there's
Yeah.
a Greek pronunciation, then there's an anglicized pronunciation,
Yeah.
and then there's the wife of the person who discovered it, whose name is Sherry or something like that.
Sherry. Yeah, it's close.
Sherry or Sharon. So
Yeah.
those are the people who want to call it Sharon.
Ursula Lowell.
Oh,
Yeah.
that's fine.
Anyway,
and then there's
but we're not talking about it anyway, so.
well, yeah. There's 4 minor satellites. They're very little, and they were discovered in either just before launching New Horizons, which
Around
went
that
out
time,
to the
part of
Pluto
the-
system,
yeah.
or like around that time. I think one of the smaller ones was discovered with New Horizons because it was so little. And this system is thought to have formed in a similar way to how the Earth-Moon system was formed, where there's this other object that comes in and hits a proto-Pluto, and then you get all of these other satellites.
We love a good collision explanation.
We do.
Yeah. So the weird thing that has just come about is we've started doing a whole bunch of really good spectroscopic science with trans-Neptunian objects that are beyond the orbit of Neptune, like Pluto, that we haven't known much about up until the launch and now use of the James Webb Space Telescope. And so one of the groups that's actually here in Orlando is observing a ton of these objects, including the Pluto system. And they've been able to kind of categorize objects in this trans-Neptunian object region into 3 different groups. But 2 of Pluto's minor satellites, Nix and Hydra,
Yes.
do not fall in any of these
Ooh.
categories.
They're misfits.
They have
They're
different
misfits.
composition on their surfaces.
So they have, they apparently have a lot of water, which is a lot like the Haumea system.
Okay.
There's also ammonia on them,
It's got red spots.
and they have red slopes.
Okay.
And Pluto has ammonia.
red slopes are like those are more
anomalously
difficult
red.
to ski than the blue or the black slopes.
Right.
But not as hard as a black diamond.
Sure.
They're not as I thought they were harder than a black
I
diamond.
don't
They're in
think
between
so.
the
I think
blue
black
and the
diamond's
black.
the hardest.
I thought black
Okay.
diamond,
Yeah.
or like double black diamond.
Yeah,
Okay.
sure.
So
Yeah.
the red are in between there. So they're reddish. They have spots that are reddish in color. They've got water and ammonia, and the
Yeah.
other ones don't.
Right. So,
Okay.
yeah,
So what-
Charon or Charon has some reddish spots on it, like Nix and Hydra, but
Cool.
Pluto doesn't.
Okay.
And Nix and Hydra have ammonia, like Pluto, but that ammonia isn't seen on.
So
Charon.
so what do we conclude from this?
We-
And,
that's-
if I'm out walking around, I pick up 6 rocks, and 3 of them are different than the other 3. I probably don't get to write a paper in a scientific journal about that.
Well, this was an abstract.
At AGU.
At AGU.
There's probably a talk at AGU,
I
but
probably
I didn't
don't
go
get
to.
to do that either. But,
Yeah.
So is the suggestion that those moons didn't form from this giant impact, perhaps, that they're interlopers, or is this telling us that they have different origin stories? Like
Not necessarily.
This one was like from a cave of bats, and the other one was from like a poison spider.
That's crazy that you said that.
How did you know
That's
that
what
was?
it said.
Yeah.
Okay.
Wow.
Okay, well, that's the end of that story.
Cool.
But yeah, they are.
It's a mystery awaiting
It's a
an
mystery.
explanation.
It is a mystery, but the cool thing about it is that it's highlighting that we're really on the the precipice
cutting
of,
edge.
cutting edge of TNO observations.
Trans-Neptunian objects.
We're learning a ton And we just don't know that much about these objects, which is cool. There's a lot of them, and so there's a lot that we can
Right. So we probably have to like throw out the old textbook and like, okay, here.
I think so.
Yeah. That's
Yeah.
cool.
Or if the Pluto system is really unique and special.
But it's still not a planet.
Yeah.
But also, yeah, I mean, it's also cool because it highlights how this is all being done with JWST, which I think a lot of folks typically think of for extrasolar things, but it's doing some really cool solar system research. And
Yeah.
the reason it's really good for outer solar system stuff is because they're move slowly as opposed to inner solar system stuff, which is harder to image with JWST because it moves so fast. And it's like dark and out there, but we can do it with JWST.
Yeah.
With its ginormous mirrors.
Yes. Yay.
All right. Before we tell you the fastest thing moving through the Earth's atmosphere, which what I'm more curious about than the answer to that trivia
Is
is
why
like,
this is the question?
yes.
Because of Parker's solar probe.
It doesn't
Well, it's
seem
just
like
like
a
how
gym
you came
style
up with
question.
that
That's
as
true.
a question.
Yeah.
But we have one more weird particle story to talk about.
We'll delve into the history of the question for
We
me.
won't go too deep into this one, but this is just, we sometimes like to talk about physics, fundamental physics, just for funsies.
As
And
one
I
does.
was-
As one does.
As one does. I just ran across this the other day. I thought it was kind of a cool thing that they've discovered a particle that when it moves in one direction, it has mass, and if it moves perpendicular to that, it does not.
Oh, come on.
No mass?
No mass.
Come on.
That doesn't make sense.
Yeah, I thought that was kind of cool.
What?
Is
That's
it
a pretty crazy thing. Now, to be clear,
tachyon?
this is no.
Is it a
Does it go back in time?
chronoton particle?
This is a thing. No, this is a thing they
Is it a dilithium crystal?
predicted like 15, 16 years ago, but has been actually experimentally verified now.
Okay.
So it's not a weird, not just a hypothetical thing like a tachyon or whatever.
I do have a
But
paper
it
on
is not.
tachyons.
When we say particle, we have to be a little bit careful. It's one of these things that we call a quasi particle, which I think
Okay.
at least one version of a quasi particle has been the sponsor
me
for the
a-
show
What's
before.
a quasi-particle?
Yeah, give us any version of a quasi-particle to ground us here.
phonon.
Is a
Oh,
phonon.
okay.
Didn't they sponsor the show not that long ago? I thought?
Phonons
Yeah.
or orbitons and magnetons are
Yeah,
all those
these are-
quasi-particles.
This is
They're
still confusing to me.
quasi-particles is a thing that people in condensed matter physics mess
Right.
with. Like if you have an electron moving through a material, then obviously fundamentally, if you just look at the electron, it has some kind of a mass and properties
And a charge,
But
yes.
as it's moving through a material, it like interacts with its environment and kind of drags stuff with it, et cetera. So it moves like a particle that has a different mass, right? Because it's moving through this soupy material or whatever. So, this kind of physicists
Well,
define
It's like
particles.
me over the holidays. I'm like I'm a particle with a different mass.
This is admittedly, I think, an absolutely terrible analogy, but I'll use it anyway.
perfect.
Can't wait.
It's sort of like a stadium wave. There's a thing that moves around the stadium.
But like when
apparently.
you do the wave in a
Yeah.
stadium? Okay.
So some quasi-particles are like holes in a lattice of atoms, and the thing that what's moving is the absence of a thing,
Sure.
Right.
right? And so that is that
like a defect.
right?
But a
Yeah.
defect doesn't
Yeah,
have mass.
yeah. I mean, that's certainly one type of these
Right.
kinds of things. But
Okay,
in
so,
any direction.
So go ahead and tell us about this one.
Okay.
So in any way, I am not this kind of physicist, so I don't know too much detail. But there is one kind of these things, and a lot of these things are like two-dimensional things, where you have like a surface, and then you flick an electron or something like that, and watch it move across this two-dimensional surface. And anyway, there's one particular kind of thing where if it's going one direction,
Okay.
it has a mass, and if it goes the other direction, it's a massless particle. Of course, massless particles move
Shut
at
your mouth.
the speed of light, and do different.
Are there
and
just like
that's-
no mass sensors in that direction?
No, it's just It's a bizarre. It's a very bizarre thing. Which it's weird, right? It has. I mean, that's not as weird as it might seem because, of course, in materials, like crystals line up in certain directions. There are directions,
Preferred
right?
directions.
It's not
There's
like
a directionality.
It's not like total empty space.
Well-
and so it's not maybe as weird as it seems, but it's still a kind of a cool idea.
I just like the way you said, hey, I'm not that kind of physicist.
Yeah.
Yeah, no, I mean, I don't mess, I don't tangle with that kind of stuff.
I'm not
but-
that kind of physicist.
He's not a big fan of collective phenomena.
Take that back. I would never. I'm not that kind of physicist.
Not that kind of, I thought it was cool, though.
Landau.
Yeah. Well, it is
It
cool.
sounded cool.
I still don't understand it at all, though.
Nah, I don't
What was the word you just said?
I said Landau. He's the one who first proposed the theory of quasi-particles was started by Landau in the 1930s. Classic physicist.
Is this particular quasi-particle got a name or a category that we can call it?
It's called something like a semi-Dirac fermion. Or something.
Okay.
Oh.
Yeah, those guys.
Yeah.
Yeah.
Those guys.
Phew.
Oh, yeah.
Don't get me started.
I feel the same way that you do.
Yeah.
Semi-Dirac fermion, yeah.
Okay.
All right, so tell me, my friends, things moving through the Earth's atmosphere very quickly. What are they?
Satellites that are re-entering.
Yeah.
Yeah, I'm thinking from outside.
Apollo spacecraft.
Parts. Right. Something that was far away that fall down a long way. That fall down a big gravity hole.
Like-
Gravity hole.
like the Artemis
Like the
1
Parker
spacecraft re-entered very
Right.
quickly because it went further out than anything else had.
Yeah. It was they were bragging about that being the fastest reentry.
I'm going to go Artemis 1.
Yeah.
Artemis
the Orion,
one.
the Orion,
The
Artemis
Orion
1.
capsule from Artemis 1.
Same.
I don't think that's correct.
No, I don't either.
It's going to
But
be some little
I can't
bit
think
or
of anything
bob.
else. A bolt from something.
Well, it had to be measured too.
The tool bag.
Yeah.
No, I don't think that re-entered yet.
Oh, really?
Maybe it did. I don't remember.
Audrey, you got a guess?
Yeah, Artemis.
All right.
Our guesses are very uninspired, Jim.
Yeah. Can we have a hint?
Oh, yeah. Can we have a hint?
So there are two things that are in contention, and
Are any of
one
us
them
right?
is you're right. Well, no, you're not right, but you're on the. But one of them is you're on the right track. It's a re-entering
Okay.
spacecraft.
Okay.
Yeah.
But you got to think something that started further out than
The
Earth
moon?
orbit, near Earth orbit.
Oh, like Orex or Hayabusa.
But was it? But
Or-
would it have slowed down?
There was
Genesis?
the Genesis
or
thing.
Stardust.
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 That's
Stardust.
Yeah.
Okay, so Stardust is almost the answer.
Oh.
Stardust would be the
Wow.
answer if not for one other enigmatic thing. So Stardust re-entered at about 27,000 miles per hour
Oh,
and
no.
was or maybe
Right.
the fastest.
And it went so
The-
well.
Probably the actually
And Yas
fastest
smiled.
thing is the manhole cover from
What?
Operate. You remember? No, you remember that from Operation Plum Bob. This is a nuclear test that they did back in the 50s.
This sounds like a
where
Rick and
they,
Morty universe.
Yeah.
They no, they
What are
put
you
they
talking
you
about?
know, back in these nuclear tests. They would put the atom bombs down in a
Oh, yeah,
tube,
in a hole.
basically in a hole in the ground, and then they exploded it. And one of them, they covered that hole with a giant, like a 20-ton manhole cover.
Okay.
Bolted it on and whatever, and then exploded the bomb, and that manhole cover went up. Now, of course, they didn't actually measure this, but they were interested in what would happen in the manhole cover, so they did have a camera that was operating at some insane speed, shutter speed.
Shutter speed,
Or
yeah.
not shutter speed. Not
Frame
shutter
rate.
Speed, but, the
Yeah.
frame rate. And it only appeared in one frame.
Okay.
And
That still gives you an a lower limit.
but they
on the
calculate,
speed.
yeah, they calculated what they thought it was, and it was something like 125,000 miles an hour.
Okay.
Going
it was
up?
moving up.
Yeah.
Going
Then it
up.
came
goes up,
back?
what
And
goes
so-
up does come down.
So we ask ourselves. I mean,
Where
that's
did it come
5
down?
times Earth's escape velocity. It didn't come back. It didn't come back. That was never seen.
But it was going
But it was
upwards
moving through the
other-
atmosphere.
Right.
It was going upward through the atmosphere.
Classic.
At 125. It probably
They
burned up.
launched a manhole
obviously.
cover on accident.
125,000.
Kind of on accident.
Maybe the
miles.
Roadster will find it.
What did you say the speed
100
for Stardust was, by the way?
27,000 miles an hour.
Okay, so this was 5 times faster, almost.
It's fi-
Wowee.
this was something like 5 times Earth's escape velocity. If it made it through, if it didn't burn up, then it escaped.
Forever.
Yeah.
Right.
Yeah, it's gone forever.
Yeah.
It almost certainly burned up, but
Right.
Sure.
Yeah.
That's real fast.
Wow. Okay.
That's fun.
That's
kinda
cool.
badass.
Yeah. How did you uncover that?
Yeah.
With
I
a
don't know.
nuclear bomb.
I think like a month ago, I was just randomly in a rabbit hole on the internet, and I saw that thing, and I was like, "What? A manhole cover?" And anyway,
That's pretty
it just
funny.
came to mind because Parker had just gone really fast. by
Yeah.
the
Yeah.
sun.
Fun.
Fun.
While it may have felt like flying on an untested rocket or a giant manhole cover, it was just another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Our theme music was composed by Richard Jarusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners in Eastern Europe. I'm Addie Dove.
I'm Jim Cooney.
I'm Audrey Martin.
And I'm Josh Cole. We're the AstroQuark signing off until the next episode of Walkabout the Galaxy.
Pew!